Physics 1102, Spring 2023, Exam 3 review. All right, this will be on chapters 21 and 22. 21 is on E&M electromagnetic induction that we've talked about, and 22 is on electromagnetic waves, in and M waves, basically light. All right, this will also cover Lab 7, which is Lenz's law, which is electromagnetic induction, and Lenz's law, and Lab 8, which is on induction. All right. So, yep. Okay. Yep. All right. So that's what lab exam's going to be on. It'll be again about 15 multiple choice and 5 problems. All right, and check the dates when it will actually occur. So, all right. So again, electromagnetic induction, we're talking about induced EMF. All right, meaning a changing B field or magnetic field produces voltage, what we call an EMF. All right. We talked about this, about how we did the demonstration for chapter 21 in the lab, how when you have, if we move a magnet, it produces a current. If you move it in, it produces one way, you pull out the other way, and if you hold it stationary, nothing happens. So we have to have a changing magnetic field for that to create the current. All right? And so this is Lenz's law, as we talked about. This is what we call EMF is minus phi over change of time. And again, this is either minus n times B times change of area over time, or N a change of B over change of time. All right, so that's what we had there, where N is the number of turns in the coil, B is magnetic field, and A is the change in area. And we went through that as far as chapter 21 is concerned. If you've heard, I didn't mention it, but this is the principle of induction stoves. Work on this principle of electromagnetic induction, because what you have is a changing magnetic field in the coils, and what you have is a pan that has metal, and a changing magnetic field creates a current in the pan, which, because the pan is not a perfect conductor, produces currents in the pan, which then produce a heat. All right. So that's what we have there. We also then have, as we talked about, electric generators. All right. And principle behind those. And so a DC produces a static current. A AC produces an alternating current, and a generator is, you turn the generator inside the coil, so you have a magnet, again, turning inside the coils. The rotating coil produces an alternating current, which then can be transmitted. So that's all electrical generation we use is by AC current. Okay. We had talked about the transformer. Again, transformer is how power is delivered by step up or step down, where voltage, again, this is with AC current, where V out secondary, V primary is number of turns over the number of primary turns. So coming in, so this is VS, VP, V out. So the ratio of the turns is that way, but the current is the other way around. V primary, V secondary, it's the other way around, because the power transmitted, power V times I, V primary times I primary equals V secondary times I secondary. So if we step up the voltage, we're going to step down the current. And that's how the principle of power generation is done, as we talked about. You step up the voltage, so you deliver much lower current, and then step it back down at the device, because the losses, as we've talked about, power losses go as I squared R, and any real wire is going to have resistance, so we double the current, we're going to quadruple the amount of energy loss. Right? And so that was the principle. That's the main principle of chapter 21. Actually, that's the idea of power generation. Why we do power at 240,000 volts instead of trying to deliver it all at 110. So that's chapter 21. That's also part of it is the video on power. So that's chapter 21, chapter 22. E&M waves, right? And the whole spectrum going down from actually 60 hertz, which is electromagnetic, power generation, all the way up to visible, which is light, all the way up to X-rays and gamma rays. Short frequency, so long wavelength here, short wavelength here, high frequency, low frequency here, high frequency here. All of them travel the speed of light of 3 times 10 to the 8th meters per second. And it's just that visible light is just the spectrum that we can see, but all electromagnetic waves travel with this speed, as we've talked about. Light is a transverse wave, as we mentioned, so that it is perpendicular to the propagation, and in that respect, so it's composed of an electric field propagating one part and a perpendicular magnetic field. So it's like a self-propagating field. That's how electromagnetic induction works. A change in magnetic field produces a change in electric field. A change in electric field produces a change in magnetic field. And for electromagnetic wave, we can think of it as a self-propagating wave. And again, we went through the whole spectrum of V is frequency times wavelength. So since all these go the same, higher frequency, shorter wavelength, and the energy is H times the frequency, where H is Planck's constant of 6.6 times 10 to the minus 34th joules seconds. So this energy in joules is equal to Planck's constant times the frequency in hertz. So higher frequency, higher energy. And so we went in that. We talked about the speed of light again, 3 times 10 to the 8th meters per second. And then the fact that light has energy with it and therefore momentum, it calls pressure as intensity. We had then light produces pressure, and the pressure for a normal source is I over C, where this is the intensity in watts per meter squared. This is the pressure in newtons per meter, and C is the speed of light, 3 times 10 to the 8th meters per second. So therefore, we end up with the power of light on, like a solar sail. This is an example of solar sails. As a possibility for inter-solar system travel, and if it reflects perfectly back, so light reflects off, then the power is 2I over C. All right, so that's newtons per meter squared, I should say, and this is watts per meter squared, and that's where we end up pressure. And then the force, again, force is pressure times area. So if you have a sail of a certain area, and the pressure given by the intensity of light, so sunlight is, that means the force in newtons will be the pressure times the area of the sail. And that's pretty much all there is to chapter 22. So there's a whole lot to the chapter, both chapters indeed. So that is exam 3 for chapters 21 and 22 for spring 2023.